So calculate T if the area of the parallelogram is a maximum. Note area of parallelogram is equals to base times height. So on our question, our base would be FC. So if I were to highlight my parallelogram that we're working on, it's this. So they give you the formula to make things a bit easier. So we have our perpendicular height here, and we have our base over here. So we need to get expressions for FC and HG in terms of T. So if we revise our information, we're told that BC is equals to 5 minus T units. So this is 5 minus T. And also we are told that HG is T units. So this is HG over here. That is T units. Now we need to create some form of ratios with T based off of our previous calculations. So in our previous question, we found that AH over HG was equal to 3 over 2. Then we know that AG is equals to AH plus GH. And we also know that, so let's write down everything we do know. We know that AH over HG is equal to AD over DB. So the best way to do this would be to use the ratios. Since we know the total length of one part, we can use the ratios for AH over HG, and we can also use the ratios for BF over FC, which is 2 over 3. Basically, what we have is that AG's total length is T, and that total length is divided up to AH, or between AH and HG, where AH takes 3 parts and HG takes 2 parts. So if we're only interested in HG, since that is the height we're going to use for our formula, we're going to say HG is equal to, we can see HG from the ratios of 3 over 2, will take 2 parts out of the total ratio, which is 5, multiplied by the total length of HG, which is T. Then we also have the same thing for FC. If we want FC, we have to look at which parts of the total FC is taking. So FC will be taking, since it was in the ratio of 2:3, FC is taking 3 parts out of the total of the ratios, which is 5, multiplied by the total length of BC, which is actual 5 minus T, and we include our brackets like that. So since we now have our perpendicular height, this will be equal to our perpendicular height, this will be equal to our base, then we can write down our area and say area is equal to base times height. So that's going to be 3 over 5, 5 minus T, multiplied by 2 over 5 times T, like that. So our area, as you can see, is dependent on the variable T. And we can write this, or simplify this rather. This 3 over 5 times 5 will give us 3 minus 3 over 5 T times that whole thing will be multiplied by 2 over 5 T. So that will give us a final expression of 12 over 25 T multiplied by, or add 6 over 5. So that would be our total plus 6 over 5 t. Actually, this is 6 over 25 t squared, since when they multiply we get minus 6 over 25. So minus 3 times 2 minus 6, 5 times 5, 25, t times t squared. And then that other one is positive and positive. That will give us 3 times 2, 6 over 5t. Then we can take now this formula for area, which is dependent on t, and find the maximum by getting the first derivative. That will then give us minus 12 over 25 t plus just 6 over 5. And we know at the maximum usually entails a value of, since our a is negative, we know that this formula for area is represented by a parabola. So the maximum area that we can get will happen at the turning point, and there we will have a gradient or a value of the first derivative of t, there being 0. So making this 0 and then solving for t will give us a value of t of you would have 30 over 12, or simplify it, you would get 5 over 2 by taking 6 over 5 to the other side, multiplying through by 25 and dividing by 12. You get that. So that is the value of t, and that's what you want. Calculate t, the area of the parallelogram is the maximum.